isothermal process. I mean when we have a constant temperature T, if T is constant. In this case, you know, if T is constant, E is constant. Delta T equals to O, so delta E equals to O. Okay, so delta E equals to O. In this case, dq equals to d omega. You can say directly dq equals to d omega. What I mean, if I add a quantity of heat, omega will be transferred directly to work. We don't have any increasing of internal energy. Okay? In the case of isothermal process, all the added quantity of heat must be transferred to work. Okay? Look, Q added, Q hot equals to omega out. We don't have any increasing of delta E. And also, if uh, if we release a quantity of heat, in this case we have work N. And I mean, if Q is negative, omega is negative. You know, omega is negative if we decrease the volume. If Q is positive, so omega must be positive. Omega is positive, I mean we increase the volume. Okay? So here it means volume increases. Here it means volume decreases. Qn, I mean it's a positive value. Q out, it means we have a negative value. So any energy that enters the system by heat must leave the system by work. Okay? Okay, it's very important to calculate all the values of delta Q, delta omega, and delta E. Okay, we come here. You know delta E equals to O, so dq equals to d omega. You have to know dq equals to d omega. dq equals to d omega, and d omega equals to the integral of pdv. You know, in the case of isothermal, we have a relation between P and V like this. Okay? You have to know this relation. It's a parabola like this. If we have here initial state and final state, if we increase the volume, we come down. If here we have the initial state and here we have the final state, if we decrease the volume, so we come up. It's like this. So I have to find a relation between P and V, and we say we can substitute the value of P by nRT divided by V. PV equals to nRT, so P equals to nRT divided by V. Okay, we have N is constant, R is constant, and T is constant. We can put it X out, and the integral of dV divided by V, out we have nRT between the initial state and the final state, equals to nRT times ln. You know, integral of dV divided by V equals to ln V. Okay, ln V, let me write, equals to nRT ln V between initial and final, equals to nRT ln V final minus ln V initial, okay, equals to nRT ln A minus ln B equals to ln A divided by B, so equals to ln V final divided by V initial. Okay. This is the final answer. It's very important to know now the relation, the sign of omega. Anyway, you know, if we increase the volume, omega must be positive, okay? So if V final is greater than V initial, in this case, the omega is positive. If the omega is positive, in the case of T constant, dq must be positive. And the opposite, if we decrease the volume, d omega must be negative. Why? Because here we have V initial is greater than V final. So len has a negative value. So omega is a negative value. So dq is negative. It means we have q cold. So here, we have a mistake here. V initial is greater than V final. So omega, here we have omega pi is negative. If V final is less than V initial, so omega pi is positive. I can. Okay. So this is about, you have to know very well what is the value of d omega in the case of T constant. And you have to know that d omega equals to dq if dE equals to O and T is constant. And you have to know also in the case of increasing the volume, we have Q is hot. In the case of decreasing the volume, we have Q is cold. What is the path between initial and final? You know, here between A and B, initially we have B, let's say B, because the volume of B is greater than the volume of A. I go to the point or to the state A, I push the piston to decrease the volume, okay? You know, PA, we can say PA VA equals to NR TA, and PB VB equals to NR TB. We can divide. You know, we have the same constant, and TA equals to TB. We get finally PA VA equals to PB VB. Okay? As I said before, if we go as a constant, in the case of isothermal relation, we have a curve, parabola curve between A and B. You cannot do the curve like this. If you do it like this, all the problem will be cancelled. Be careful. It must be a parabola like a sliding object. Slide, not like you don't have a peak. So if you go from A to B, it will be down. If you go from B to A, will be up. You cannot do it like this. If you do it like this, also it will be cancelled. So you have to know very well the shape of the curve, of the path between A and B, A to B. You know, we have d omega equals to dq equals to n r t ln v final divided by v initial. If I take this state where vb is the initial state and va is the final state, here we have va divided by vb. Okay, as vb is greater than va, so ln is a negative. So omega is negative and q is negative. Anyway, you know, if we decrease the volume, omega must be negative. So dq is negative. In this case, we have q cold. Okay? The opposite case, if we increase the volume from the initial state A to the final state B, okay, like this, and we can apply the same d omega equals to dq equals to nRT ln V final, it will be B divided by A. We increase the volume, so d omega must be positive and dq is positive. Or you can say as VB is greater than VA, ln must be positive. So here we have Q hot. This is by calculation, you can prove Q is if Q is positive or negative. Without calculation, you can say if we decrease the volume, we increase P and T in general. Okay? Why? Because you have PV equals to nRT. If we decrease the volume, you have to increase P and T. To keep T constant, we have to release a quantity of heat. And the opposite. If we increase the volume, we decrease P and T. To keep T constant, we add a quantity of heat, Q. It will be Q hot. Anyway, you can find the value of Q by calculation. We go